Right now, we're very fortunate if you guys could jump up and we'll transition to the next one. Yep. And to my University of Maryland guys, why don't we just leave it? Yeah, take that, but we'll leave the rest for now and we'll get it after the talk. We just want to make sure we make the most use of our time because we are incredibly lucky and fortunate to have a late adjustment to the agenda. We are very pleased, very fortunate, very honored to have in her first public speaking opportunity, the new Associate Administrator for NASA's Science Mission Directorate, Nicola Fox. She is here today to talk to us. It's going to be a pretty quick talk because we had to squeeze it in and we have to get out of here by a certain time, but I would love to welcome Nikki to the stage right now. Thank you. Big round of applause for Nikki. Thank you.
Well, thanks so much. It really is a pleasure to be here. And I'm really honored to actually have followed that amazing panel discussion. And I had all these thoughts in my head about what I was going to talk about. And I pivoted at the last minute because of the incredible thoughts that were shared. And I am a mother of a middle school daughter, and so I really resonated with the comments about how important middle school is, and I want to double down on that because elementary school kids are always full of hope. They're always excited, everything is new and bright and shiny, and when they get to middle school, that's where it really stops. And so, I have been putting a lot of focus and energy into inspiring and talking about the importance of actually not just STEM, but all subjects, and how kids need to really keep all their subjects going, because you can be the best scientist, engineer, mathematician, but if you can't write a paper, you got a problem. You can want to be the best possible artist, you can want to be, a singer, or whatever. Math is in every single thing that you do. And so the importance of keeping all of the subjects going. I actually am one of these really weird mothers that goes to every single teacher on the parent-teacher conferences. I even go to the physical education ones. Neither of my kids are very sporty, but I like to tell them that, it's important. Every subject is important. And so, this kind of inclusive nature, how we inspire people, how we lower boundaries to getting into science. And so, one of the things I want to talk about today is that 2023 is the year of open science. And, making sure that all our data are open, accessible, and usable to everybody. And for us at NASA, not only does that mean that, we're getting more people able to use our data, but we also want to be really intentional about lowering the boundaries and letting more people come in and use and be inspired by NASA data. You heard on Wednesday about the heliophysics big year, and we are using citizen science as a tool in the big year to, again, open up to a much broader population the access to our data. You don't need to have a PhD to be a citizen scientist. You just have to be really, really curious. And that's what we want to inspire at NASA. And so I wanted to take a stab. I've just realized they gave me all these nice charts and I haven't used any of them. There you go. So that was my first theme, was an integrated program. So how we talk about science in order to actually motivate people. I really want to start everybody thinking about talking about NASA science as one broad theme. We all wear badges. I'm a heliophysicist. I started off as a planetary scientist, but we have earth scientists, we have astrophysics, and we have biological and physical sciences, and we can all talk really well about our little sort of pieces. But what I really want to hear is people talking about science as one broad, exciting platform. And so this sort of theme of an integrated program, and this is actually the first time I get to talk about the whole science fleet. But if you look up here, you can see just an incredible array of missions. And so I started trying to think about a story arc. And so I will probably get penalized for using the same mission twice in this, but bear with me. So if I start off and I anchor the story with DART. And so we all saw last year the amazing spectacle of, actually, it's funny, it's the image that no normal scientist wants to see, was the one that we all got excited about with DART, where it went up and then it stopped. Yeah, any other scientist would be horrified, but we all stood there cheering away just a few few hundred meters down the road, as we saw that image and we saw DART plow into that asteroid. And of course, that's being, something that's going up and out. But in fact, we also are bringing back samples right now. On September 24th of this year, OSIRIS-REx will return with samples from Bennu. And Bennu is important because it's actually, it has signatures in it from the very beginning of our solar system. And so by actually looking at those samples, we will learn about the physical and the chemical makeup of that asteroid. That will tell us about life, maybe even how life formed, how planets formed, how the oceans formed, which is an incredibly important thing for us, and inspired the next large mission from astrophysics. As a result of their recent decadal, the Habitable Worlds Observatory is the highest priority. So that's going to be the next big telescope for astrophysics. And of course, that builds, it'll look at the biological signatures and find habitable worlds, find planets in other stellar systems that could potentially have life, which of course is one of the major themes for NASA. It will build on the technology that we already have. It will need a telescope the size of Webb. It will look in the same kind of wavelength ranges as Hubble, and it will need a coronagraph, very similar to the technology that we're developing and demonstrating on Roman. But you cannot talk about astrophysics without being inspired by all those amazing images from Webb. And I'm not going to steal Mark's thunder because I'm sure he's going to have some amazing images to show you. But you get weepy when you see the new images from Webb because they're just so incredible. And one of my favorite ones is a globular cluster that is sort of surrounded by sparkling stars. And of course, each one of those stars has an influence. It carves out its place in the universe, and it has a sort of sphere of influence around it. We call those astrospheres. Well, did you know that our planet, our particular sun, also has an astrosphere, and we call it the heliosphere. And we are using many, many different techniques to actually study our heliosphere. One of them right now, of course, is the Voyagers that have left the heliosphere and out in interstellar space. But another one that will be coming soon is the IMAP mission that is going to sit at the L1 point and look out and tell us about the fragile boundary between where the sun stops and interstellar space starts. It also, from the L1 point, will sample all of the plasma coming from the sun. And so it will tell us about all of the acceleration processes and all of the stuff coming to us from the sun, which of course is important because that fuels space weather. And we also have a mission that is launching later this year, the atmospheric wave experiment that will go up to the ISS and will study airglow and tell us how space weather is kind of driven in the upper atmosphere. So in some ways, it's kind of protecting our planet, which of course we will be doing with the Earth System Observatory, which over the next decade will be launching a series of missions that will actually look at our planet in all different ways and look at some of the challenges that we face. In about a month, we will launch the TEMPO mission, which will take high-resolution images of pollution across the entire North America, from Mexico City up to the Canadian oil sands, and going from the Atlantic to the Pacific. And then also we just arrived in India on NISAR mission, which is a joint mission between NASA and ISRO. And it has a very innovative technique for using two different kinds of radar to actually look at how our planet is responding to things like volcanic eruptions and tsunamis. And so, again, planetary protection brings me back to DART. That's I get penalized for using that one twice. But then also I wanted to highlight from the OSIRIS-REx again. Bennu is actually, there's a high probability that it will impact us here at Earth at the end of the 22nd century. So by actually studying that and taking the samples, we can learn about what kind of mitigations we would have to take in order to redirect that with a mission like DART. Also, the importance of bringing samples back. Recently, we reopened the cache and brought out samples from the Apollo era again, from the lunar regolith. And recently, our Biological and Physical Sciences division sponsored work with a university in Florida to actually grow plants in the lunar regolith. I'm going to see if I can remember the name. I think it's Arabidopsis, I think is the name of the plant. And they grew them in these samples and were able, I mean, they didn't do particularly well, but they grew them in the lunar regolith. And so, you know, again, importance of samples, which brings me to Mars sample return and the excitement of what we've seen with perseverance and ingenuity with our new images from the Martian surface. Also collecting those samples and laying them down on the Martian surface ready for Mars sample return to go and get them in a few years. I think I covered everybody. But that's the kind of story I would love us to sort of weave together, to actually tie all of NASA science together, because it's doing these things that really highlight the excitement of what we do, and hopefully we'll be able to sort of inspire the next generation to want to do those with us. With Mars sample return, I could even go on and say, you know, that's the excitement of studying Mars. And we'll be very soon launching the ESCAPADE mission, which is a great example of partnerships with commercial partners, with Rocket Labs building the spacecraft and it being launched on a Blue Origin New Glenn. And I would be remiss, so I've mentioned Tempo that'll be launching next month. We also will have our first 2 launches of the CLIPS program, so the Commercial Lunar Payload program. We'll have the first one is Astrobiotic Peregrine, and that will be studying all kinds of different interactions with the lunar regolith. And then about a month after that, we will launch the Innovative Machines Nova-C mission that is actually going to demonstrate precision landing. So these are just a few things that are going to take place in the next couple of months. Yes, that all I've gone through is really happening in the next month to year. Well, Habitable Worlds Observatory, Mark, I'll give you more than a year to do that one, but you know, but get going. So anyway, I'm really happy. I'm really excited to be here. I'm really, really honored to be selected to be the Associate Administrator for Science. You know, in the spirit of inclusion, I actually shared a lot of my own personal issues and challenges that I faced with my team, and I got a lot of sort of feedback that you know, it was appreciated that I actually shared a lot of myself. And so I know one of the themes in the last talk was sometimes it is difficult to share your own stuff, but man, it's really worth doing. And so I'm going to kind of finish there and say thank you so much for having me today. I really, really look forward to seeing all of you at meetings and conferences, and I really am glad that we're back to in person. I think it was Eddie who noted before, it's so hard to actually meet people in the virtual. And so, you know, I do intend to be up and available. And so please do come. Please don't like see me at a coffee at a conference and think, oh, I probably won't talk to her, she's busy. Please, it's quite lonely sometimes being in these positions. So please do come and talk to me. I would appreciate that. Thank you very much.
We have time for maybe 1 or 2 very quick questions, not statements, questions. So if does anybody have a very quick question?